Okay, so now we have been talking about topographic maps. We are going to move on and talk about how to draw those lines in. So we looked at what topographic maps were, we talked about what they show us, and now we're going to talk about how they're drawn a little bit. So our learning target for today is I can list the rules of drawing isolines and draw them following those rules. And our success criteria is I can draw an isoline that connects points of equal value and determine if an isoline has been drawn incorrectly. So we're going to look at, there are 5 rules for doing this, for drawing them in. We're going to look at what they are, and then we're going to look at some examples and make sure we understand how to draw our own in. So just to talk about a little bit, maybe a review, but what are isolines? These are lines that connect points of equal value on a field map. A field map is anything with a measurable quantity at every location. So these are all examples of field maps. These are 3 different kinds. I have earthquakes, I have temperature. This is just a practice example. It's probably also temperature, but just all these numbers are things that you can measure. So things that you can use an instrument to get a number for. Some examples of isolines are isotherms. So in this word here, therm is like thermal. These are lines connecting points of equal temperature. We use this in meteorology. Another one that we use in meteorology or weather is isobar. Bar like barometric pressure. So these are lines connecting points of equal barometric pressure. When you see weather maps on TV, most of the time they're showing air pressure on them. And then what we already talked about was contour lines, and these lines connect points of equal elevation. So this is what we looked at when we looked at our topographic maps in the last video. So anything that you can have a value for, you can have an isoline for. So like I said before, if you can measure with an instrument and get a number, then you can make an isoline out of it. And some of them have specific names, like isotherm and isobar, and some of them don't. It depends on what you're looking at. So let's get into the rules. There's going to be 5. Rule number 1, this is sort of the definition of an isoline, but it connects points of equal value. So if I wanted to draw in an isoline connecting in the values of 10, I would connect all of the number 10s. Pretty straightforward. Rule 2 is isolines are gentle curving lines. That means no sharp corners, no double or messy lines. So this example is done poorly, right? We don't want this. We want nice, smooth curves, just like we had in the previous slide. Rule 3, isolines are always closed curves, even though the map might only show part of it. So when you're drawing them in or when you see them drawn, just be aware, eventually they will close into a loop. But if this box here, okay, is all that's being shown, then you don't see the part off of the map. So you may not see all of it, but just be aware that it is there. This is probably the most important rule number 4. Isolines never cross. This means that one point has 2 different values. So if you think about it, does that make sense? Can you have one spot with 2 temperatures? It can't be 30 degrees and 40 degrees in the same location. So here and here, okay, that's not good. You cannot have one place with 2 temperatures. You cannot have one place with 2 elevations. You can only have one measurement for every single location. Your lines might be very close together, and it might sometimes look like they're crossing, but they cannot. And then the last rule is isolines are usually parallel-ish. So they tend to follow a parallel trend. That does not mean that they're exactly parallel, but they will kind of follow a curve. So this is a very simplified example. And then I'm going to pull up this map again from the last PowerPoint because I like it. And just show you, again, here we have these lines, and they're following a trend. They're not perfectly parallel because they're not going to be, but they are following the same kind of trend around. And this is going to help when you draw them, because once you have a single line drawn in, it's much easier to draw in the other lines, knowing sort of what the trend should look like. So if you have a field of numbers, there's a lot of numbers here, and you're going to highlight your data points. That's our first thing, okay? So in this example, I'm going to go through and I'm going to highlight all of the 60s. I want to draw in an isoline of 60. Let's call this temperature. So we'll call these isotherms. So first thing I'm going to do is find all of my values of 60 that are labeled. Okay, this is fairly simple to do. Sometimes you may not have so many points given. All right, so now what you need to do is figure out, there are some areas here, like in here, right? I have these 3 points, I have these, but I've got a lot of areas where there is no number 60 given to me. So I need to figure out, where is the value of 60? So I need to fill these gaps in the data in. For example, if I have 64 and 54 here, the number 60 exists in between these. These are all measurements. So 60 is going to be somewhere in between here, and that's where I would put my point. I'm going to do the same thing here. The number 60, the value of 60, is in between 66 and 55. So that point is going to go somewhere in between those two. And I'm going to continue to do that as I go along. And as you do this, and as you get more practice with it, it does get easier. And you don't necessarily have to put all of the dots on a map. I mean, we're going to be a little bit limited with how much we can do this remotely. And then once you have all that done, you're going to connect the dots. And this is our 60 ISO line. This is violating one of the rules that we talked about before, but it's kind of hard to draw smooth lines on a computer. So just be aware, this should be a nice smooth line, not a kind of squiggly line. But there it is. And then all we would have to do is move on to the next value. Okay, so we connected our dots. And if we go on to the next value, let's say we wanted to do 70, and then 50, and 80. Now we said before that ISO lines are always closed curves. So these 3 examples are closed curves, meaning they create, it's not a circle, but it's a closed shape. But the 50 line goes off the paper. That just means that somewhere on the edges are more 50s. If you were to extend this map or this field map out, there would be more 50s there. But we don't have them all. It's a space constraint. So that's why it's going to the edge of the page. And that's pretty much it. So we're listing the rules. So there were 5 rules, and then drawing them. And then drawing an isoline that connects points of equal value, and determining if an isoline has been drawn incorrectly. So you're going to have to think about those rules to draw them in. We're going to do a little bit of practice now. And then also looking at lines and saying, is this drawn correctly or not?